Hey guys, so welcome back to the second part of this video. So we've done the previous part in this video where we created an output stream called a YOLO.text file, and it just generates random numbers using this random access file stream modification, what we did it previously. And now for in today's video, we're gonna first get this same code. So we're gonna control A and C this, and then after that we're gonna control V this over here by just copying this and by just modifying it a little bit and to just read the file. Okay, so we have the file present. We have it as YOLO.text stored in our directory, specific directory where the executional file of this is available, and for it to run we're gonna use the iOS input function. Okay, so it's YOLO.text, and now we just need to read it. So now we don't need to like generate something out of it, so we're just going to delete all of this. And instead of a number 2, we don't need any numbers, so we're just going to delete all of this junk too. That is also deleted. And the thing what we need now is a file stream file, which is going to open as iOS input mode, and not even this num minus minus. Instead, we're going to use the file, and we're going to use dot good function. So this good function tells that if the file is good to read. So unless the file reaches the end of file marker, okay, this is a character at the end of a text file, you're gonna read every single thing in the file. So for that, I'm gonna first declare a character, because a character could be represented using any integer, an alphabet, a special character. It could represent anything. So we're gonna include not an integer but a character, and I'm gonna name it as C. And now over here I'm gonna do something called that get function, and what I'm gonna do is C is equal to get function, and before that we have that file, and we're gonna do dot file get function. So get function like this, using this, and that is it. We're having this get function that will read every single thing in the file, even the spaces, even the necessary spaces and the white spaces like the \n, the new line, the spaces in between, the tabs, everything will read through this get line function, and being more precise, the get function. And then after that, we're gonna display in our console screen using the cout C. So it's gonna read every single character by this. So it's gonna do 1 space 2 3 4 until the end of file marker reaches. So after that I'll just close this, and I'm gonna save this first as something. I'll call it 64 is already done. 65. I'm gonna execute, compile, and run this baby, and look at that, all of it got read from the text file and on my output screen. So whatever it was on my text file is now written on the console screen, and it was that easy. Okay, so one more thing I wanted to tell you is that not only this good function, but you could also use another thing called the end of file. Okay, so the end of file function indicates the end of the file, literally. So when I'm saying while not operator, so this is a not operator, well, you not reach the end of file, do this. So this is another way to do this, and you can see by executing and compiling, we're going to get the exact same thing. So we got the exact same thing as output. So that was with the input operation. And now what I wanted to tell you is the functionalities that's totally special to this. And the fact is that you could include input as well as output in random access. That's what it differentiates standard static sequential read and write to more dynamic read write using random access. And by using this pipe symbol, this pipe, you could include iOS : out. So you're now basically in both modes. You could use input and output in your code, and it gets generally more easier for you. So in this case, I want to explain one thing over here, was the fact that I introduced one more thing called iOS : app, and this app is append. And I told you that whenever we use the output command, our data is always overwritten and it's totally gone, and then it starts from a new fresh file. But with append function, we don't have to necessarily overwrite the pre-existing data. It will just add the data and append it to the end of the file. So for instance, my text file, which was already existed in the C++, which is called YOLO, and it has this clever coding and all this numbers, and when you see at the end, it ends on 2. I want something to be written after this. For that, we use the append command, and it's not gonna like delete all of that before. By using this, we're gonna use the same exact procedure, but now what we're gonna do is, instead of reading through this get function, we're gonna write. So we're using the file, so file, and then we'll do something like, what do you mean? Okay, and yeah, we'll have an end line over here, and then we'll add something like, programming is fun. Okay, so for that case, we don't need this end of file function because we're now writing to it. So for this purpose, we'll use another number case, like a test case, what we previously did beforehand. I'm gonna say it to the screen, enter a number, and I'm just gonna say it like that, and let's just give it a space so that it looks a little more pretty, and then give a num over here, where it's already defined before. I forgot to delete that. Okay, now num minus minus. So we save this code, and now let's execute, compile, and run this baby. Okay, and enter a number. How many times you want to repeat that phrase, what do you mean that programming is fun? I'll say I want it repeated 20 times. Okay, didn't show anything on the console screen. Going back to our C++ YOLO file, and now I maximize this, and you can see this is already from the top, and it's supposed to be, oh my god, there you go, 20 times. What do you mean? Programming is fun. Awesome. So this was done with this, and now you can see now it ended up over here. So that was the last of it, and now you could also append it and add even more to it. So that was with append function, and we now have other functions to deal with, which is called binary. And for a binary, you're just gonna have that output mode in binary. In text, you can't understand. So if you have something in but a decimal, you're just gonna have in binaries like this. So that's in binary mode instead of having it in ASCII mode, what generally people understand. Then we have others like ATE, what was at the end. All right, so another of the function modes, or the flags, what we call them, was an ATE, the at the end flag. So what does this do is that it generally, when you're speaking, is gonna start from the end of the file. So in essence, whenever a file is open in input or output mode, the file will be processed from the end. It's gonna basically start from the end. And one thing's for sure, when you're having it in reading mode, like when you're inputting, right? So you have nothing and you'll have nothing because you're basically starting from the end. And common sense says that when you're starting from the end of the file and there's nothing there, what are you going to input? So it will just read nothing and return the end of file character, which is eventually what you reach at the end of a text file. So it will return the end of file as true and execute. So that was handy for at the end. And now I'm going to talk about the one thing that I really wanted to give note and give light to, and that was if we have in and output mode together. So by standards, we have also those things in the same convention too. We could have iOS app, and we could have iOS ATE, and we could have iOS binary or iOS truncate together. But we could use even more than this. We could use iOS ::AVP. So we have no bound. There's no bound in the program. If you're syntactically correct, the sky's the limit. Okay, so if it's input and output mode together, how do I basically do this? So there's another functionality that appears, and before that, I'm going to be making a text file over here. So I create a new text file, and I'm going to name it as something called, I don't know, Mojo. And Mojo will have numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So to be honest with you guys, this is just a regular Mojo text file what I've created on my desktop screen, and it has 10 digits starting from 0 and concludes to 9. And what I want to do is that I want to use random access on this and try to use and change it. And I know it sounds silly, but believe me, this is a really good programming practice for professionals. And once you get the hang of it, you can use it to solve big files and big and huge files where there's tons of data in. So for starters, we're just going to use this. So how am I going to start this out? The thing is that if it's in input mode and it's in output mode, first of all, the name of the text file has to be changed. So it's Mojo. And now Mojo is in input and output mode. And we use two new functions called seekg and the other called seekp. So these two functions one is called seek G, which is get, seek get, and the other one is called seek put. So seek get basically reads the things in the file, and seek put means puts the things, meaning the output one is this, and the input one is that. So for seek G, we're starting it out. What we're gonna do is we're gonna use seek G. So we're gonna use the file command, which is our file, and we say dot seek G. So seek G is a function, and it has two basic parameters, and the one parameter it has is an integer. We generally call this as a long integer. Okay, so we're gonna have a long integer, and the other parameter inside of it is gonna be the position to it, whether it's in the beginning, so we could say iOS beginning, or is it at the end, or is it somewhere else in between the file. So first of all, I'm gonna get this straight by introducing you to this command. So if I say beginning, now basically to make this even more simpler to revise, a programmer does is what a program does when it reads a file. It has two file pointers. One is the reading pointer, and one is the writing pointer. So the reading pointer and the writing pointer both start at the initial 0 position, and the 0 position is not here but here. And once you move over here at one step, can we get this zoomed in? Okay. So once you're moving one step, you are basically jumping to the first location. Then you're jumping to the second, then third, then fourth. So you got my point over here. So the pointers, what we talked about seek G, is basically a pointer, flag pointer, which is called the input pointer, and it points over here, and it's at 0 location. And once it moves over here, it has 1 location. And once it moves over here, it has 2 location, and so on. So what I could do over here is now by writing this code, it could move its pointer position. So okay, so after writing this seek G, meaning seek get, moving the position from the 0 initial stage to the first stage, meaning over here, from here to here, we have to write seek G1 iOS beginning. So now we have another function, and that's called tell G. And this tell G means tell the get position, where the flag pointer is. So now the flag pointer moves one position further and changes its location. And now we're gonna and this function is basically returning just a number. So it just returns the position where the flag pointer is located now, the current position. So for the basic purpose, I wanted to explain over here that either we could have beginning, either we could start from the end, or either we could start from the current position. So the current position also deals with the same kind of scenarios where your flag pointer is situated. So by default, it's beginning, and I wanted to print it out which location, so I say console output, I say file dot tell G. This is the syntax of the code, nothing inside, no input parameter, and just end line over here. So if I execute this code, compile and run, you're gonna see one location. So I see the one location means that the pointer changed its location to here. And if I want to change it to somewhere like 7th position, I save this, I once again compile it and run, and now it's gonna move to the 7th location, and you're gonna see now it's gonna move from here 1, 2, 3, 4, 5 all the way to the 7th position. So now that was with reading. Now we have the similar task as compared to writing. So for writing purpose, we have file dot seek p, and this is seek put. So for instance, we still have the same 7. It still starts at by default 0, and then we have this iOS beginning. Now we have over here the same. We're just gonna console output file dot tell p. So tell p and end line. So it's gonna tell us the location of the flag pointers of the put one and the get one. So execute, compile and run, and both are in 7th location, and that is absolutely correct. What happens if I say the first one was in 2, meaning the input flag pointer was in 2 position and the output flag pointer was in the 7th position? Doesn't it mean that tell G, which is the G part over here, be on 2, and the seek P, which is the tell P, be 7? No. When this pointer, the most recent pointer, whether it's the input or whether it's the output, will determine both of their locations. So if it's 7, means the most recent is 7, and before 2, so that means both of them shift to the 7th location. So execute, compile and run, you're still gonna see the 7th location. And there you have it. So if I say something over here as 2, and this was at 7, you're gonna still see that most recent one will be executed. So compile and run, and it's gonna show us that it's 2 because it was before 7 and now after that 2, so it's shifted, and both the input and output pointers are now in this 2nd location. So for instance, I have this number over here 0, 1, 2, 3, 4, all the way to 9. And I want to change something over here like this 2. And I want to change it to a 9 too. Can I do this with random access? Yes, I can. So I'll tell you how to do it. So by deleting this tellg, because we don't need that, we have this CP pointer, which is the output pointer, which is the writing pointer. So this is the put pointer, writing pointer. The G is the get pointer, the reading pointer. That's an easy way to remember. And now I want to modify it. So I use the file variable name, and I'm just gonna modify it with the value 9. So I'm just gonna do this, semicolon, and this is just gonna keep on telling me the location. So I'm gonna run this code, and what you're gonna see now is that you're gonna see that pointer position still at 3 now. Now what does this mean? It means that it basically wrote something on that position. And now it shifted its position to 3rd. So it was generally in the 2nd position. Once it wrote something on the 2nd position, it shifted to the 3rd position. That means our code has worked, and it gave an effect to the text file. So when I open this text file again over here, YOLO, and I think it wasn't YOLO, it was Mojo. So when I open up Mojo, you see now, what do you see? 0, 1, and then 9. So the code changed it. It was in the 2nd position, changed it to the 3rd position, and it's now right here. So it was over here, 0, 1, 2, 3. And now it's in the 3rd position by changing this, and now in the 3rd position. So that was with random access. I know I didn't get that deep into this topic. If you want more videos related to this topic, please comment down below so that I can make videos according to your interests, and I will see you guys probably in the next video.